Okay, here I am, just building up those circuit boards that we made up. Well, actually building up a different set. I changed the design slightly, so I'm actually, I made some new boards and thought we'd go with these. And just going to build them up again to make sure that they do exactly what they want to do, or what I want them to do anyway. And I just going to put the components in, solder them up, and we'll see how they go. I could do 2 at a time here, just to show that they are identical. I've got pretty much 2 of everything. Very low component count on these boards, nothing excessive. They don't need vast amounts of anything really, so yeah. Right, okay, we're ready to test the first board, and nothing special. You've got a 555 timer, you've got an IRF 510, and the only reason for using 510 is because that's what I had. You've got your 2 timing resistors there, you've got your gate resistor there for your from your output to there, just to limit your current. It's not a great deal of resistance. On the output we have this rather big board full of LEDs, and on the input we have the power supply. Now I'm going to drop the volts slightly, just take it to 12 volts, and hopefully we should start to get some flashing. I suppose the thing to do is check my schematic and check my wiring first. Capacitor positive, pin 8. Pin 8. We've got another flash. Looks like my timing figures are slightly out. I shall have to investigate. Back soon. So there we go, an easily rectifiable board design error. So and there we go, that's flashing at the rate of whatever we set it to. Now the way we could increase the flash intensity would be to put a bigger capacitor there so that it would drain quickly, and we can try that out by just getting a random capacitor pack like so and putting it across the relevant terminals. So let's just temporarily attach this. Let's kill the power supply for a second. And we should get a flash when this connects, because obviously it is charged. Yep, there was a little one there, not a huge flash, but a flash nonetheless. So again, power supply. Now if we now, it has made the light significantly brighter, but it's given it a longer delay time, so obviously that amount of capacitance is far too much. But you know, we can experiment with that value to get a reasonable sort of hang time without too much delay, so that the next flash is still quite bright, but without needing to be excessively delayed and use too much persistence. But yes, it's drawing minimal current. It's only drawing sort of 250 milliamps, whereas normally this board in constant use would be drawing around about 3 amps it draws. So you know, efficiency wise, that's doing pretty good. Right, I'm going to do some experiments with capacitor values, and we'll get back to you. See you soon. Okay, so after a little bit of playing, we found that 4,700 microfarads is actually a good size. Obviously having 6 of them is too much, but just having a single one gives you enough extra current, which it can dump fairly quickly, therefore increasing the brightness of the lights without having too much persistence on the LEDs. As you see, they die pretty much instantly. There's a little bit more persistence there at the lower frequency. But it is going to be a compromise between persistence and brightness. That is actually quite bright. You know, the MOSFET here is staying, almost ice cold at that frequency. Let's take the frequency right up. It's still drawing. At peak, it's stabilised around about 400 milliamps, which for a 5 amp MOSFET is perfectly stable, perfectly adequate, and it'll run that without heat sinking. Yeah, I think I'm going to go with that. So the first job I've got to do is fix this board so that it actually matches the other one, rather than have the design fault, which was my fault, and then test it out and attach it to something, and see how it gets on. See you a bit later. Okay, so here we are, probably part 2 of the video. I've dismantled the heater shell basically, and I've got one of the blank LED boards that I had, and it's actually working out surprisingly easy to do this conversion, because the center hole where this screen mount actually lines up dead center with the center hole on the the reflective surface, which actually is held in place by this bracket. This reflective bit screws into this center hole of the bracket, so that all assembles like that. Now all I need to do is put a screw through the back onto a standoff pillar this side, and then mount this on a short standoff pillar from here and run the wiring to the outside. The other thing that I've found with this lighting unit, apart from the fact that the finish is all flaking off, so that's why it's not on the bench at the moment. The screws are particularly rusty. This is actually the box for the circuitry, or for the electrics, and if I actually cut this board down in size, I should be able to mount it within the confines of the existing box on the back of the unit, which means that I won't have to do anything. Okay, the capacitor will have to mount inside the reflective part of the housing, behind the board, but realistically speaking, that's not going to be much of a challenge at all. So that's probably the way I'm going to work with this. I'm going to literally just cut the board down as it stands. I'll probably use a Dremel this time instead of a Stanley knife. Good old mechanical power, and just put it together. The glass is completely filthy, so that obviously needs redoing. The reflective surface, I don't know whether that's showing up so well, but it actually has quite a lot of sort of like white powdery dust on it, which I'd want to take out as well as clean off all these flakes of stuff. But apart from that, it's so reminiscent of the cheap Chinese floodlights. In fact, this is a Chinese made floodlight. I would imagine the housing and the ceramics are pretty well consistent with a large industrial floodlight. Now, as you see, the terminals there, the heat from the original lighting bulb has actually charred this this heat resistant wire, so it's certainly had a lot of physical stress there. What's that say? 250 volts, 2 amps, maximum 500 watts, and the tube that they put in there was 1.2 kilowatts, so they've exceeded their own rating by a good power, at least double. Yeah, that's probably why the contacts in this thing are, I think the words to use are charred to buggery. They really are chewed quite badly. Now, the tube I've actually already taken out and thrown in the recycling because it didn't look too healthy, and I didn't want it shattering on the bench with little shards of dark red glass. So that's the point we're at the moment with this. When I get it fully assembled, I'll probably put the this is it finished assembled video up. But until then, I think I'm going to say thanks very much for watching, and hope you enjoyed the video. See you soon. Bye bye.